Hello, we are discussing about GATE 1999 ECE paper. Look at the given program, it is in 8085 and also it has given contents of memory locations from 2000 to 2002. First one is what the actually program is doing, and second one is at the end of the program execution what are the contents of accumulator, BC and HL registers, and what are the conditions of carry and zero flags, the contents of memory locations given below. These are the things we are going to find. It is a 5 marks question. So first we will start from this one. Move immediate C, 03. That means C register is immediately moved with the data present in the instruction. So C is equal to 03. Next, LXI H, 2000H. Register pair HL is loaded with 2000. So HL contents are now equal to 2000. Move A, M. It is moving, simply copying the contents from the memory location into accumulator. Which memory location? Memory location is always pointed by HL register pair in 8085. So A is equal to contents of HL. Contents of HL means contents of 2000. That means contents of 2000 it is given as 18H. Now accumulator will find 18H. So after execution of move A, M, contents from the memory location pointed by the HL register pair are loaded into accumulator. So now accumulator is loaded with 18H. Next, DCRC, decrement the C register contents. So after execution C will be equal to 02. Next, INXH, increment the register pair HL contents. HL is now 2000 and increment the register HL register pair. So 2001, now HL will be equal to 2001. Move B, M. So copy the contents from the memory location pointed by HL register pair into B register. Now B is loaded with contents of 2001 which is 10H. Okay, it is given that one it is 10H. So now B will be consisting of 10H. Compare B. Compare B. Whenever you are going with compare B, the actual operation comparison are always based on the subtraction. So internally microprocessor will subtract contents of B register from A. Contents of B register from A. So A minus B is going to place, but no register is modified. Even though it is performing subtraction internally, that in subtraction is only used for the comparison purpose. It is not the intended operation. So no register contents either A or B is modified. Contents of A and B registers will remain same, but only flags will change depending on the comparison. So here comparison means generally you may get 3 cases. Okay, either A may be greater than B, either A may be less than B, or A equal to B. If A is greater than B, what is the meaning? If A is less than B or A is equal to B. When A is greater than B, okay, there is no carry flag is generated, there is no borrow generated. A is a larger number, you can simply subtract smaller from the larger. So no carry flag, that means no borrow is generated, so carry flag is 0. Definitely A is greater than B, so you will get some answer. Okay, so that is not equal to 0. You will get subtraction result as 0 only when A is equal to B. In all other cases the result is non-zero. So non-zero means 0 flag is doesn't set. So these are the two conditions affected by this comparison, carry flag and 0 flag. Carry will reset and 0 will reset if A is greater than B. Okay. If A is less than B, then definitely you cannot subtract larger one from the smaller one. It requires a borrow. Borrow will be indicated with the help of carry flag in the 8085. So CY is equal to 1 to indicate a borrow required, and definitely the subtraction result is non-zero, so 0 flag doesn't set. When A is equal to B, when A is equal to B, it doesn't require any borrow, so carry flag will reset but the result will be 0. So 0 flag will set. These are the three conditions. Now if you observe for the first case, B is 10, A is 18. So for the first time, what we can say is A is greater than B, that is 18 is greater than 10. So whenever 18 is greater than 10, this is a condition we are going to get. So carry flag is 0 and 0 flag is 0 for the first case, first comparison. Jump on no carry, loop 2. Since there is no carry generated, the control is moving towards loop 2 now. Decrementing the C register, so C will become 01, previously it was 02. Now C is 01, that means 0 flag doesn't set, because the contents of register C is not 0. So 0 flag with 0 flag is equal to reset. Jump on no 0, loop 1. Now from this one it is moving into loop 1. So it is moving into loop 1. In loop 1 again HL contents are incremented. Now HL contents will become 2002 and move B comma M. Contents of memory location pointed by HL register, that is 2002, is loaded into B. Now 2002 contents are loaded into B, which are nothing but 2B it has given. So these are the contents 2B, 2BH. Now B will be consisting of 2B, and now comparing B. A is at 18 and B is at 2B. Now for the second comparison, you will get this condition. A is less than B. Whenever A is less than B, what it is doing? It is making carry flag to set and 0 flag will reset. Jump on no carry, but carry is if there is no carry, it will be jumping into loop 2. Since carry is not generated, you are copying the contents of B to A. So now A is equal to B is equal to 2BH, because while copying the contents from B to A, register B is not modified. A will be loaded with B content, so A is equal to B is equal to 2BH. That means our aim is to place always the larger number in A. Previously also A is at 18 and B is at 10. Since A is 18, there is no carry generated and we are moving into the next memory location because A itself is larger. In this case A is smaller, so that we are copying the larger number into accumulator. So out of given memory locations, this program is going to find the largest number present and that will be loaded into accumulator finally. And the accumulator contents are loaded into 2100 location, as the next instruction is STA. So now we are at this memory location. This instruction move A comma B. After move A comma B, now decrement C. So now C will become 00, previously it was 1, and 0 flag will set, because contents of C register is 00, to indicate that 0 flag is set. And jump on no 0, loop 1, because a carry flag is set, jump on no 0 condition fails, so now the control is moving downwards towards STA. Store accumulator at 2100 location. So now the contents of 2100 will be having the contents of accumulator, that means 2BH. 2BH is loaded at 2100. Now we will see the program first one is nothing but it is going to find the largest number given in the memory locations. You can also increase the memory locations in this program, that can be increased to any number if you want to make the memory locations given as. Look at this one. Out of this one you can increase 2000A. That means total locations are going to be 12 locations. 0 to A, 11 locations. A means 10. So the 2000 till 2000A, 11 memory locations. By that time C must be loaded with 11. If you are making it as C must be loaded with 0B, then it is going to find the largest number present in that out of 11 locations. Out of 11 locations. Whichever the value is higher, that will be finally in the accumulator, and that is placed at the 2100 memory location. So 2100 location as well as accumulator will find the largest possible value out of given memory locations. Okay. Second one, at the end of the program, what will be the contents of register A? Register contents A is equal to 2BH, and register contents of B is also 2BH. Okay, and register contents of B is also 2BH. Register contents of C is 00. Okay, register contents of HL register is at 2002, that is final location 2002. Okay, this is final location. And condition of carry flag and zero flag, this is very important. Okay, after executing DCRC, decrement, okay, look at this one, decrement we have given. After decrement, C is 00, so zero flag is 1, but carry flag done. So after DCR instruction, all the flags are going to be modified according to the result except carry flag. Carry flag will be in the same condition as usual. So before this one, if you observe, the carry flag is going to be at 1 position. After comparing B for the second time, carry will be at 1. After this one, we know the carry is at 1. Jump on no carry. Okay, it won't execute since carry is at 1. Move A comma B, it's a data transfer instruction. It doesn't change the value of carry. Carry will be not affected by this instruction. So CY will be maintained at the same previous position. And next, DCRC, CY is at 1. Okay, because it is not affecting the carry. All other carry flags, that is sign flag, parity flag, zero flag, auxiliary carry flag are modified, but not carry. Carry will be not modified. That means it will be in the same condition just before this instruction. Whatever its value, it will contain the same one. So CY is equal to 1. Jump on no 0 doesn't affect any flags, and STA is also doesn't affect any flags. That means the values of ZF and CFY are maintained till the end of the program. So at the end, carry flag will consisting of 1 and zero flag is also consisting of 1 value. That is, both will be at the set condition only at the end of program. Okay, and contents of memory location. Even though you are using contents of memory locations, the contents of memory locations are not modified. Okay, so 2000 will be as it is. It will be consisting of 80. 2000 will be consisting of 10. 2002 will be consisting of 2B. 2100 will be consisting of 2B, which is the highest number. It is in the accumulator at the end of the program. Okay, even though A is equal to move A comma M, move B comma M. If you are executing these instructions also, the source is not modified. That is, contents of memory locations are not modified. So contents of memory locations are at the same positions for 2000, 2001, 2002 with same values. 2100 will be having the highest number out of these 3 memory locations, which is 2B. That's all. So this is the answer for this question. Thank you.